Welcome to the U.S. Military Test Prep channel by Study.com. My name is Eric, Marine Corps veteran, and I'm an ASVAB test prep expert. In today's video, we'll practice computing perimeter and area of two-dimensional composite geometric figures, which could include circles, when given the geometric formulas as needed. This will help you prepare for the mathematics knowledge exam, which is one of the subject-specific sections of the ASVAB. Let's take a look at our first problem. Use the figure below to answer the question that follows. The figure above is a composite figure of a rectangle and two semicircles. What is the area? 336 plus 24.5 pi centimeters squared, 336 plus 49 pi centimeters squared, 336 plus 98 pi centimeters squared, or 336 plus 196 pi centimeters squared. All right, so let's think about what this problem tells us. So first off, we know that it's a composite figure which has a rectangle and two semicircles. So let's start with the rectangle, and we can see that piece right in here. Because it's a rectangle, we know that this side is equal and parallel to this side, and this side is equal and parallel to this side. So that means that we can apply all of the formulas that apply to rectangles. Now let's consider the semicircles. So we have two semicircles here, and right here. And a semicircle, semi simply means half. So it's two halves of a circle, and two halves make a whole. So essentially what we have is one whole circle that is split into two parts. But if we just consider it as one whole circle, then all of the same formulas that apply to circles can apply here and help us to solve the problem. We also know that the line segments here with the two hash marks are 14 centimeters. And that splits the circle exactly in half, which means that that is the diameter. So our diameter of the circle is 14 centimeters. Which is really helpful because to find the radius, which we know is what we'll need for a lot of formulas involving a circle, equals half of the diameter, which equals 7 centimeters. And for our rectangle, we have a length equal to 24 centimeters and a width, which is also serving as the diameter, of 14 centimeters. So let's try and put together a formula that can give us the area of the entire composite. So the area of our composite shape is equal to the area of our rectangle plus the area of our circle. All right, well, let's refresh on what these each mean. So we'll call this area of C will be our composite, just for easier writing. The area of a rectangle is the length times the width, plus the area of a circle is pi times the radius squared. Well, we've got all this information, so let's fill it in. So the area of our composite equals the length, which is 24 centimeters, times the width, which is 14 centimeters, plus pi times our radius, which is 7 centimeters squared. That's going to equal the area of our composite. Well, it looks like we've got a lot of information here. Let's just keep working through the problem. So the area of our composite equals 24 times 14, which is 336. And we've got centimeters times centimeters, so that's centimeters squared, plus pi times, and we have 7 centimeters squared. So 7 centimeters squared is 49 centimeters squared. So the area of our composite is equal to, we can rewrite this to match the answers over on the left, 336 plus 49 pi, we can pull this centimeters squared out to the side. So our answer over here is B, 336 plus 49 pi centimeters squared. Great job! Use the figure below to answer the question that follows. And we have a composite figure here, which has a number of dimensions assigned. What is the perimeter of the composite figure above? 32 centimeters, 34 centimeters, 36 centimeters, or 38 centimeters? All right, so we can recall that perimeter is essentially the sum of all of the different sides. And it looks to me like all of the sides have a dimension provided. So let's just name each of the sides, and then we can add them up, and that should give us our perimeter. So we can call this side A, this can be B, we can call this one C, D, E, and F. So our perimeter equals A plus B plus C plus D plus E plus F. All right, so let's fill in the dimensions. A equals 8 centimeters, plus B is 4 centimeters, plus C is 5 centimeters, plus D is also 5 centimeters, plus E is 3 centimeters, plus F, 9 centimeters. So if we add these together, we've got 8 plus 4 equals 12, plus 5 is 17, plus 5 again is 22, plus 3 is 25. And then if we add 9, we get 34. So our answer is 34 centimeters. Great job! Use the figure below to answer the question that follows. We've got a composite shape with a couple of dimensions applied, 24 centimeters squared, 36 centimeters squared, 48 centimeters squared, 40 centimeters squared. What is the area of the composite figure of a square and a triangle? All right, we know we're working with an area problem. Let's really read the question carefully to see what information we're given that might be helpful. Well, this looks useful to me. They're telling us that it's a square. So it could have been a rectangle, but it's a square, and that means that all of the sides of the square are equal. Since they all each have one hash mark there, that's denoting and helping us remember that all of those sides are equal. So the area of our composite shape is going to be equal to the area of our square plus the area of our triangle. So the area, and I'll just write C for composite, just to make it a little easier to write out. So the area of a rectangle would be base times height. But because we know that this is a square, they're all the same, it's just a side length squared. So a side length times a side length is going to equal the area of our square. So then plus the area of a triangle is 1/2 base times height. So let's see what we have over in our figure. So we know the side length are all 6 centimeters. Because we know this side length right here is 6 centimeters. So all of our side lengths are 6 centimeters. So we've got 6 squared plus 1/2 of base. So what's our base? That would be right here. And we can see that that's 4 centimeters. So 4 times, and our height is denoted right here. That's our side length also, so 4 times 6. So if we keep working this out, 6 times 6 is 36, plus, and we can do it this way, 4 times 6 is 24, and then divided by 2, that's our times half. So we'll keep breaking this down, equals 36 plus 12. Or the area of our composite is 48 centimeters squared. So our answer is 48 centimeters squared. Great job! Okay, that's the rundown on computing perimeter and area of two-dimensional composite geometric figures, which could include circles when given the geometric formulas as needed. If this video helped you out, give it a thumbs up, drop a comment with any questions or topics you'd like us to cover in the future, and don't forget to subscribe for more U.S. military test prep content. I'll see you in the next video. You've got this.